All right, so I guess I wasn't real clear in the videos. When I asked you to make a slope field, go ahead and use a slope field generator. So like this one here, for instance. Um, Something that I would like to point out to you though is on this, what I want to say, on the when you're doing these problems, make sure you start looking at them and getting comfortable with them, because x squared plus y squared is always positive, right? Minus 1. Okay, is it possible that this thing is equal to 0 anywhere? Sure, when x and y's are positive and negative 1, all the way around the corner, we should see 0 slopes here, and we do. So let me get rid of these guys here for you. Okay, so then we said that this one, number 23, said that y of 0 was 0, so that's cool. Okay, and then hit enter there, submit, and that's what our curve would look like, you see. So then at 2 over here, so you can follow the curve right there. So at x equals 2, somewhere. Oh, Betsy. Oh, darn it, you hippie. Anyway, you're supposed to be able to run right on that red curve. You should be able to get really close to it. And so right about 2, it's going to be right at. So there's a couple things you can do. So you can go like this right in here and get pretty close and go, it's about 0.77 or thereabouts. You can also click on this, okay, and your initial point is 0, 0. And by the way, we will, there you go. So 0, 0. And then if you scroll down a ways, you will find that at 2, it's approximately equal to 0.77. See that? So that's what I want you to do. So you just copy this table. By the way, this table is using, it's probably using Newton's method. I wouldn't know for sure, but I think so. Or not Newton's, I mean Euler's method. So just be aware of that. Yeah. So there's that. Go ahead and just cut this out and then paste it into your homework if you want. Or send me a snapshot of it. That's what I would do. Or I guess you can print it out and cut it on a sheet of paper. I don't care. Something like that. We wanted this one though. There you go. That's the one that you want. Okay. And so again, just get in the habit when you look at these guys. When you look at this here, remember, just always keep in mind that this is going to equal 0 somewhere. Well, okay, well, when is that going to happen? Well, it's going to happen when x squared plus y squared is equal to 1. You're like, oh, when it's plus and minus 1. Yeah, kind of, but this is a circle, right? So if you go back and look at that picture right there, you should see a circle kind of right around in there where you had 0 slopes kind of going on, okay? 0 slope right there at 0, 1. I'm sorry, at negative 1, 0. At 1, 0, there's a 0 slope there. At 0, 1, and at 0, negative 1, those were all 0 slopes. But then, yeah, just be aware of that. Okay. So technically, anywhere on that circle would have been a negative slope. So 2.4 also was one that you wanted to look at. Number 25. So 2.425 is maybe right here. Yep. So dVdt is equal to 32 minus 1.6 v, and v naught is equal to 0. Beautiful. Okay. Right. So helicopter, this and that, use Euler's method, and go 0 to 2. Step size of 0.01. What percent off are you? Okay, and so here to do what percent off I am, I need to solve this actually, right? So, God dang it, you jackwagon! I need to actually do this, and because I can actually check myself, which I think is pretty sweet. That won't always be true. Sometimes you won't be able to check yourself. So if you let u equal 32 minus 1.6b, then du is equal to 1.6eb. But then I don't have that, so I have 5/8. Or if you like the decimal better, good for you. So negative 5/8 ln of u equals t plus a constant. So it's going to be negative 8/5 or 1.6 again, if that makes you happier. I think I like it better. Alrighty then, let's play musical chairs. Right? Right. Okay, now, so 32 divided by 1.6 should be 20. No, I know what it is. It's 20. Minus, and then of course this is just a constant, so it's a different constant, but a constant nonetheless is equal to V. Now, we said at 0, it was 0, so that's hot. So for that to be true, this would be 1, C would have to be 20. Well, there's our equation. So notice that we're interested in what happens at 2, as we were said to predict for. So it's going to be 20, you jackass, 20 minus 20e to the negative 1.6 times 2. There we are. Okay, so that's exactly what we should get in Excel. So let's go to Excel, and let's go have some fun with it. Now, there's a couple of different ways. I don't really care. I mean, I think the way that I like to do it, I mean, that is with naming cells, is kind of cool. You don't have to. I can show you with the dollar signs, whatever makes you happy. I'll probably just do dollar signs, I guess. All right, so T, V, and y V prime, I guess, here, a little V primage, and a little step size. So initially they want us to use 0.01, I believe. Correct. And so I'm going to go 0, obviously, with my first, and these are both 0 initially. And then equals this fella plus the step size. F4. Oop, what did you just do? F4. F4. Push the right button, stupid. There you go. Jackass. All right. So, of course, it's going to need to take us down to 202-ish. Right? Because we didn't start at 0. Somewhere in there, I think. Bam! All right. Now, listen. What is the slope? The slope is equal to 32 minus 1.6 times the velocity. Oh, you whore. Times the velocity that you had. Bam. Okay? Now, that is his velocity. All right, cool. Well, so then, here we go. Now, what new velocity will he have? Well, he'll have his old velocity plus his new rate, right? That means that's his acceleration, right? 32 times delta x right there, okay? And then, of course, give it the old F4-age. Okay? So then if you drag this baby down, bloop, and then you grab both of these and you paste them like so. When we get to the bottom, we should see we're at like 19.2. Now, what were we supposed to be at? We said we were supposed to be at, oh, fart, when did I have it? 19.184. You're like, dude, that's pretty close, bro. It's not far off. It's not far off at all. So if I do 19.2, where am I at? 0.558 minus this guy is that divided by that guy. Yeah, so we're off by 0.1%. That's pretty good. It's pretty good. We're a little over approximating it. Now that makes sense if you think about it. Kind of makes sense if you think about what's going on here. We know that our actual equation is of the format we're under, we're overestimating. So let me think about what that is. Okay, so our equation was going to be, what was our equation? We wrote it down over here somewhere. 20 minus 20 e to the negative 1.6x. Zoom, 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 like so. Yes. Yes. Yeah. Yeah, so we're going to be approaching 20. 20, by the way, would 20 feet per second, or 20 feet per second would be this guy's terminal velocity in essence. Okay, and so yeah, there we have it. And we are going to be approximating with these little lines going across the top of it. We should be underestimating, but for some reason, whatever. There it is. Doesn't really matter that much, but just curious. Now, back in Excel, what a guy can do, and you can do this on a separate page. You can copy. You could literally copy this entire page like this. You can just do a duplicate tab, right click. Where's it at? Rename, copy. There it is. I was looking for duplicate and can't figure out why I couldn't see duplicate. Hey, there we go. Cool. So this is the duplicate. So 0.005. Check it out, dog. This is exciting. Everything updates except, wait for it. Oh, dude, we're only to 1 now. So grab all this crap here. And matter of fact, what I'm going to do is just grab. Actually, I'm not, because this is in as a formula. Just click and drag it. Whee! I overshot it, I think. That doesn't matter. Let's go back this way. Whoopsie daisy. 19.195. Awesome. So 19.19518 minus that guy. That divided by that guy. And you can see we're off by, that's 0.0005, so we're off by 0.05%. Okay, that's what they're looking for on those. Hope that helps.